Hello all, previously we have seen how to insert a node at the end of circular singly linked list. Now in this particular video we will see how to insert a node at a specific position by using a user defined function called insert at position, which is taking two arguments. First one is int x, that means the node value, which will be passed from the main function, and in position, that means in each position you are going to insert a node. So these are the two parameters for this function. So first create a node. This step is very obvious. First create a node by using a malloc function. Once the node got created, assign the value. So whatever the x value, that x value will be assigned in temp data, so that the value will be assigned. Now check if the list is empty. If the linked list is empty, then head becomes null. If head double equal to null, then whatever you are going to add a node, that will be the first and last node. In this case the position won't matter. Okay, even if you give position is 10 and the value is 25, but the linked list is empty, then there is no significance in the position value, because the head is equal to null. The condition is true here. For that purpose you create a node, assign the value. If the head is null, then make a circular reference so that the single node points to itself. How do we do that? Temp next is equal to temp, so that the node will point to itself, and make head and tail. Initially head and tail will be null, right, in this case. Now make head and tail points to this newly created node, so that the circular reference will be maintained. Okay, now if you want to add a node at the beginning, that is position double is equal to 1, this condition will be satisfied. And we have already discussed in our previous video what if the position double equal to 1. So you can refer insert at beginning in the circular SLL. The same code is here. Okay, now for example, if we have multiple nodes, then how this function behaves, let us see. For this purpose I have taken one example. I will explain through that example, that would be better. From case 3 onwards I will take an example, and I will show you how this function behaves. So let's get started. For that now let us take a circular singly linked list as follows. We have 4 nodes which their memory addresses are 100, 200, 300 and 400. As you see, head is pointing to the first node and tail is pointing to the last node. And create a node with the temporary name, and assign a value. Now let us assume I want to add 35 at the location number 3. Let's see how this function behaves. For that purpose, create a node and assign the value. Let us assume this newly created value, that memory address is 250. Now check if the head is equal to null. Since there are some nodes in the linked list, the head double equal to null will becomes false. So we will skip this function. We will skip this condition, and check if the position double is equal to 1. Now in this case the position is 3. Is 3 double equal to 1? The condition false. So this condition is also skipped. Now step number 3, the next step would be take another pointer called current. So take another pointer called current and points to head. So the updated linked list diagram as follows. So initially head is pointing to 100, right, and current is also pointing to 100. That means the first node itself. We have to traverse this current. So take another pointer called current, point to head. After that, the purpose of the current pointer is to find the previous position minus 1th node. So if the position is 3, now this pointer will move to the second position, so that we can add a node in between 2 and 3. Okay, so for this purpose you need to have a one pointer. For that purpose I named that pointer as current. Now we have to traverse the linked list to find the position minus 1th node. Okay, so for that purpose I am using while loop. While count for counting purpose, the count value initially 1, the count is equal to count minus 1. So count less than position minus 1 and current next not equal to head. Since we don't have any null values in circular singly linked list, now whatever the current next value, whatever the lost next value is become when it becomes the head value, that means it is the end of circular SLL. So we are taking that condition in the while loop. Okay, so let us see how this tracing works. Iteration number 1, count is initially 1, is count less than position minus 1, 3 minus 1, 3 minus 1 is 2, 1 less than 2 is condition true, and current next value, what is current next value? As per this diagram, the current next value is 200, is 200 not equal to 100, condition true. So we will move the current pointer to the next node. So the updated diagram as follows. Initially current at 100th location, now current is moved to 200th location. So now the iteration again checks. Now count value becomes 2. Is 2 less than position minus 1? Position is 3, 3 minus 1, that becomes 2. Is 2 less than 2? Condition false. We have to terminate the loop, so loop will be terminated here. Now the next step is insert a node after current pointer. So after current pointer, whatever the newly created node, that should come here as per our input. We have to add 35 at the third position, right? Now, so assume the linked list diagram as follows. Now somehow we have to add 35 in between 20 and 30. So for that purpose, the next code will be temp next. Whatever the temp next value, this is empty, right? Whatever the temp next value, that will be assigned with current next. Current next is 300. This 300 will be assigned in temp next value, so that the link will be created with respect to temp and 300. So updated diagram as follows. So after that particular statement, so I will show you this statement. Temp next is equal to current next. So what is the current next value? Current next value is 300, that will be assigned in temp next. So the updated diagram as follows. So this temp and 300 nodes will be interconnected. Now we have to create a link between current and temp. How do we do that? Assign the temp value in the current next. Okay, so the updated diagram as follows. So assign the temp value in the current next. So after that the updated diagram looks as follows. So current next value initially 300, right? So assign with temp value. The temp address value is 250. So current next becomes 250 now, so that the link is formed. So this is how you can insert a node at a given position. So some conditions I have not checked. I will explain those conditions. So first condition, what if you given a position out of range? For that purpose you need to check if count is less than position minus 1. So that will be the out of range. You can delete that particular node. Okay. For what if you are going to add a node at the last? So we need to make for that purpose. So for example, if you want to add a node at the end, that for that purpose there will be one condition. If current double equal to tile, for example, if current position and tile position both are same, then point that tile to this newly created temp node, so that that will forms the so that tile will be updated to the last node. So these things I have not checked. Please check on yourself. Please check from your end. I will show you the execution. So execute, compile and run. So I will add some nodes initially. Insert at end function. Through insert at end function I am adding some nodes. So insert value 10. I will add again 20. I will add again 30. I will add again 40. So I will display the initial linked list by using a choice called 7. So this is the initial linked list. Okay. Now I want to add 35 at position number 3, right? That's what I have discussed in that example. So for that purpose, I am using a choice called insert at position. So enter your choice. The choice number is 3. Enter value and position. So value is 25 and the position is 3. So those are added. Now I will display the updated linked list. So by the choice called 7. So this is how the newly linked list is. This is what the newly linked list is. So that's it for this video. I will see you in my next video. Thank you.